Let's finish this set of videos on Java Review by looking at a program that consists of three different classes. Three different classes that we set up, and then of course we also use other things like string and things like that, but we don't include that in our count. So we want to build a very simple system to test a counter class. So what is the counter class? Let's take a look at, I'm going to go back a couple of slides and you will see this counter class. It's just a simple class with just one data member, a private int count. Remember, we want to make all our data members private. And then we have a constructor and a query method, a method that returns the current value of the count data member. And then a couple of methods to change the value, to increment it, and then to reset. Okay, so that's our simple counter class that we want to sort of test. So how do we set up a simple system or a system to test out this class? We set up, so we call the model, the thing that we're trying to model is counting, and so that consists of just a single counter class that we just saw. Now we try to avoid putting in a lot of system.out.print lines. Actually, this is a good rule of thumb, is to avoid system.out.print lines or avoid reading stuff in from the user as much as possible in every class. You want to set up very simple classes that do one thing or two things or a few things really well, and don't put out output and don't depend on how to put out output. Why is that? Because you might use, instead of the system.out, you might use a graphical user interface, in which case all of that stuff should go in another class. So that's called usually the user interface class. And in this course we will use two kinds of user interface, that is a graphical user interface and a text interface. In this particular example we will use a text interface. So we will use system.out.println to display values. But later on we will also use graphical user interfaces. And so we want to separate all the user interface stuff from the thing that we're really concerned about, which is counting. In this case, we want to set up a counter. So we want to get rid of all of that stuff having to do with interacting with the user out of this and put all of it inside a special class. So how does that look? Here's a simple class. This is a public class, so it's going to go into its own file, countertester.java. It has one private data member, which is an instance of the counter class. Remember, that's the thing that we're trying to model, and so it's called the model actually. So we're trying to model the counter class. We're going to try to model counting, so we have an instance of the counter class. Then we have a constructor in which we create an instance of this counter object. So remember, the constructor, the main job of the constructor is to initialize data members. So here we're initializing, we're creating an instance of the counter class. In this particular example, all we have then is just one method, and this is a command method, that is a method that does stuff. And what does it do? It just prints out various things, increments the counter, and remember, increment count is a command method in the counter class. Then prints out some more stuff, it resets the counter, and then prints out some additional stuff. In this case, there's no input from the user, it's all output going to system.out.print lines. So this is very important. We'll try to do this in all our classes. Note one thing. All of this stuff that has to do with printing is going into this class, that is the tester class, and we keep our other class. I'm going to back up a few slides. If you take a look at this, there are no system.out.print lines in this class. That's the way we want our classes to be set up. If you're trying to model something, something that happens, something that we do in real life that is counting things, let's say I realize this is a very simple example, it's meant to be simple, but note that there's no system.out.print lines. We take all of that stuff and put it into a separate class. That's the kind of thing we want to do in all our programming projects. We want to have all of that kind of stuff, system.out.println. Let's say we put that in a user interface class. In this case, our user interface class is the counter tester class. So keep that in mind for all of our future assignments and projects and things. Okay, we need one more class. That's the third one, is the class with the public static void main. Remember that all Java programs start in one public static void main. So in this case, what we're doing is we create an instance of the counter tester class. It's called tester. We create it, and then we call the start method. And we'll see many cases where this is all you need in a public static void main. No matter how big your graphical user interface might be, typically we will set up a very small class with a main method. This is sometimes called a driver. This drives the tester program. And I'm going to back up one. Here's where most of our stuff happens. And the thing that we're really interested in is counter, which is an instance of uppercase C counter class. Okay, so remember this structure. We have a simple, very simple class for main in which we create the system, the user interface in this case. The user interface takes care of creating the thing that we want to model, which is the counter, and then drives the test. So it prints out stuff, calls various methods, and prints out some more, and then calls another method, and so on. Okay, all of the user interaction happens here. Okay, when we use Eclipse, it turns out that we don't have to deal with finding exactly where the file is and all that. Eclipse sort of manages all of this stuff for you. You don't have to worry about this. But if you ever did have to figure out how to run stuff from the command line, this is sort of how you do it. You say Java and then the name of the class that has the main method. And so when you say Java test, in this case, test is this class. So you do have to compile it. That's what it's called. You have to take the Java compiler and run this through the Java compiler and all that. The thing about this is Eclipse does all of this stuff for you. Let's say you set this up, you hit save. As soon as you hit save, the Java compiler gets called and checks and makes sure that this has no errors. If it does, you have to fix them before you go ahead. And then what you do is once you get a class that has no errors, you click on the Run button in Eclipse. What that does really behind the scenes is that it runs this command. It says Java and then the name of the class with that has your public static void main. And then running this will produce, in this case, just 6 lines of output. Okay, so that was a complete system with 3 classes, with all the user interface in one, concentrated in one class. Now let's take a look at some, this is one of the last things I think we will look at. We look at objects that wrap primitive values. So there, remember we have ints, floats, doubles, and all of these things have a corresponding Java class. And ints have the integer class. Floats have the float class with an uppercase F. So this is actually a class, not a primitive data type. As much as possible, if you want speed, you want to use ints. You can use integer in the place of ints, but your program will get bigger, especially if you have a lot of data. You'll notice the difference. If you have tiny data, if you just have a few int variables, yeah, I guess using integer instead of ints won't cost you much, but this is actually quite a bit less efficient because this takes up a lot of space. Same thing with Boolean. Lowercase b Boolean is a primitive data type, and there is a corresponding wrapper class called Boolean with an uppercase b. There's also, for char, C-H-A-R, lowercase c, there is a corresponding class called character. For lowercase b byte, is an uppercase b byte class. For lowercase s short, there is an uppercase s short, and this is the class equivalent of the lowercase. So what do these things provide? They're not just bigger versions of shorts or ints or floats or doubles or longs. What they have is a lot of methods that allow you to do all kinds of transformations or conversions and things like that. Okay, and later on, very soon we'll get into what immutable classes are. A classic example of immutable classes is string. A string class is immutable. That is, you cannot go in and change individual things inside, individual characters inside a string. You just cannot do that. There are certain ways that you can use strings. You can, if you try to call the string.replace method, what you generate then is a completely new string. You cannot go into a string object and muck around with individual characters. So these wrap a primitive value into an object so that you can have methods. So a regular int doesn't have methods. Regular float or double doesn't have methods. These things, they do have methods. So that's the advantage of using this. You can set up methods that do certain operations. So how would you use this? Let's say you have an int, you can say integer and integer equals an int. So if you do that, what you will get is you'll get whatever values in an int goes into an integer. Now here we do the opposite. We say integer and integer is equal to new integer, and we give to the constructor the value 2. That means we set up this integer object with the value 2. So inside this integer object we have an actual int. So that's why we say that this integer object wraps this primitive data type int. And the same thing with floats and doubles. Okay, so each instance of this integer class is immutable. You cannot go in and actually change it. Once you've created it, you cannot change this. You can only create new integer objects for, let's say, 3 or 4 or 9 or 20 or 100 or negative values even. You cannot go into this object and change this data member to whatever value you want. That's just, you cannot do it. Okay, so it has a single int property, and the value of the property is given during creation. You can always access it using this method int value, and you can have corresponding methods for doubles and floats and so on. Java 5, that is versions of Java after Java 1.5, which is also called Java 5, unfortunately, has this thing called auto-boxing and auto-unboxing. What does auto-boxing mean? It means that if you create an instance of the integer class and assign it an int, then this is automatically boxed or put into an object. This is implicitly converted to a new. So the use of a new keyword, and you say new integer 3. So these things, if you do this, basically you end up doing this. You can also unbox, and you can say int something equals whatever object you had set up before, in this case an integer, which is an instance of the integer class. And not only that, you can put it in an expression, like you can say this object plus 1, and Java is implicitly converts this and says, okay, when I see an integer and a plus 1, I have to get the int value first, which returns an actual int, adds the int 1 to it, assigns the result to this int value. This is called auto unboxing. It does it automatically. Okay, so this is the end of Java Basics. Next lecture we will look at basic object-oriented design, its abstraction, composition. And before the next class, definitely try out all of this above examples. Especially you want to do things like pre-increment, pre-decrement, post-increment, post-decrement, things like that. Get used to how those kinds of things work. If you understand those things, chances are you understand most integer arithmetic expressions.